Jonathan.
Thank you. It is true, I am Jonathan. I'm from Autodesk, and I'm here to talk about specifically opinionless enforcement of opinions on operational secrets. Yes, talking about opinionless enforcement of opinions on operational secrets. That closer? Later, not Thursday yet. I don't know how many people here know about Autodesk or what it is we do. There's some words up there if you want to read those while I say slightly different words. We enable people to make things. The more interesting things I have come across have been 3D printed prosthesis, prosthetic hands. There's USB powered soccer balls, or rather USB batteries that are powered by kicking around the soccer ball they're contained within. I met somebody last year at one of our internal conferences who is working with a group out in Boston to assemble genomes in an attempt to fight cancer. So there's lots of really interesting things going on there. Also civil infrastructure, cars, video games, a lot of stuff coming out of Hollywood. It's very unlikely that you've come across things that you have not come across things that Autodesk has had some hand in. So where Autodesk is right now, for a bit of background, I am in the cloud operations group. I am doing whatever DevOps is supposed to be at Autodesk, and I'm helping us essentially get all of our stuff kind of consistent because we are, after all, a decades-old software company that has only recently started coming out of the habit of essentially shipping Gold Master desktop software, where you have that Gold Master image and then it's done. It's the user's problem at that point. Any bugs? Well, it's probably Windows. Have you tried reinstalling Windows? Tough habit to break. So now we're transitioning to the cloud via the data center. So we had a bit of stuff there, played around with private clouds, and now going out to whatever the cloud is. An interesting thing about us is we've got a lot of very specialized software. Most of it, much of it, some of it still trapped within desktop applications. Some examples of some of the software I've come across that I don't have a personal use for, but I find fascinating. Ignoring the design software that's used to create 3D prosthetic hands and little USB battery soccer ball mashups, we have things that are very specialized, such as crowd and traffic simulation for freeway systems, conduit routing for how you actually run an optimum amount of electrical conduit and data conduit in a skyscraper, how to make that skyscraper get the, the Platinum LEED certification to be environmentally friendly. A lot of super focused stuff there. That being said, we've been around. We just celebrated our 35th birthday. There was a lot of interesting swag that people were giving around that they've been keeping for the past 35 years. And it's not uncommon at this shop to see people who have been there for 15 plus years. So where we are right now. A lot of applications, a lot of ways of doing things. Not only have we been developing our own IP in-house, we've also been acquiring a bunch of companies. All of these projects, all of these acquisitions, they come with their own opinions, generally manifested as technology choices, but not always. So we have now unsustainable orchestration tooling. There's a lot of it, huge variety of it. Trying to get things in a single path can be a little frustrating. We are, however, working super hard on getting to whatever that paved road looks like for us. And we're evolving from a DevOps team to a unified DevOps teams. Anyone want to take a guess at what the distinction is? That's okay. A good idea for indicating what a DevOps team is. So we can see the photo there of silos. Each one of those silos represents a product team. Everything flows through the DevOps engineers who aren't allowed out of that little box in the front of it. Not necessarily unified. It's still essentially throwing things over the wall. And we are moving away from that. And we're fairly certain that the light of the tunnel is not actually a train. We think it's kind of a door that's being hung open, not sure yet. So in terms of some of the challenges we face, we're coming from super traditional IT service management. We have very traditional infrastructure. You name it in terms of, not to give too many, there's a lot out there. There's a bunch of stuff out there. And we're very aggressively, again, moving to the cloud. And in this case, the cloud for us is Amazon Web Services. Starting to talk a little bit about the feelings a bit. One of the more interesting challenges here has not had anything to do with the technology. It has not had to do with the opinions that people are manifesting as technology choices, but it's just that culture shift. Trying to shift towards something where it's, there's more of an emphasis on cross-team collaboration, on projects and tools, rather than the team that's making that tool, where it becomes something that's shared across the organization. So there's probably some interesting or familiar products on this. How are we driving this move towards more collaboration? Well, Enterprise GitHub and Slack are the cliche examples here. So we have a group chat system, throw back to IRC, but it renders GIFs in line, and you can have all these conversations in quasi-real time. There's Enterprise GitHub, which, if nothing else, what it brings us is something to facilitate pull request culture, something to essentially put in the gates for peer review, where other people can look at this project and look at whatever your changes are, and not even necessarily be on your team or in your time zone, but you can tag them and they can look at it, and it turns into more of a community endeavor. I was actually super happy to see we have an open source policy and process. There's a Jira workflow mapping this, and it's actually been super smooth to get stuff open sourced. I hadn't heard of the term inner source prior to coming to Autodesk. Anyone here heard the term inner source before? Look at all those hands that aren't going up. Awesome. We'll talk a bit more about that in a bit. The bottom line of what we're trying to do, and this is a huge part of what I'm trying to push, is transparency and collaboration. There's pockets of collaboration within the organization, but in terms of how we manage something, key is operational secrets. That's something that everyone should be involved in, if not necessarily in making the tools, although that would be cool too, in making use of the tools and developing the best practices and the documentation together. At the end of the day, we have to ensure that everyone feels empowered to participate. And I feel like it's relevant to mention that during my first draft of this, it said, ensure every engineer feels empowered to participate. No, it's actually everyone. Some of the challenges have been around like project managers and scrum masters and making sure that they're taking into account the fact that we need to pay more attention to our individual team's goals to actually get to where we need to go. So other forms of how we're getting there. How are we making use of some of those technologies and ideologies, so to speak? Well, we're trying to provide some tools which follow some basic Unix tenets. The two I care about the most is portability over efficiency. We have people running Windows on their desktop and Mac on their desktop, and I'm not sure if they're supposed to, but I've seen a few people running Linux on their desktop. So we need the stuff to be able to run everywhere. And we want these individual tools to do one thing super well. Like, we're not necessarily sure the tool is what we want in the long game, but it's a stepping stone in terms of creating that paved road that we all want to be on. Other than pushing the transparency and collaboration and everyone holding hands writing tools together, also putting a huge emphasis on data models, specifically for operational constructs. There's lots of aspects of this out there now, usually in the form of opinionated JSON, opinionated YAML. You can probably see where I am going with this. So I've got mixed feelings on YAML, and to kind of touch upon those, I'm going to read this quote from Le Man of La Mancha, which is, "When life itself seems lunatic, who knows where madness lies? Perhaps to be too practical is madness, to surrender dreams, this may be madness. Too much sanity may be madness, and maddest of all, to see life as it is and not as it should be." So clearly, I've got a lot of feelings about YAML. At the end of the day, the anecdata I've collected and I've sourced from people indicates that developers, they're grumpy about anything with semantic white space, but they're a little okay with YAML compared to having to write out configuration files in JSON or configuration files in YAML. And as much as we strive to have generators for these configuration files, sometimes you still have to type some JSON or some XML. And YAML seems to be a little friendlier. I'm not sure why. Less punctuation, different punctuation. It's hard to tell. In terms of the YAML itself, seem to mostly just be following the trend that parts of the industry has set, kind of following behind Ansible, YAML to reflect what that data structure is going to be. Who here knows about HashiCorp Vault? Let's start talking about operational secrets. Oh, I see more hands going up than for inner source, so that's not surprising. So for the rest of you, HashiCorp Vault gives you a set of web services around managing operational secrets. It has some really neat things in there in terms of dynamic secret provision. So you need access to an AWS account. You ask Vault for AWS credentials on a particular role, and it gives you either an IAM or STS role credentials that are tied to that particular account, tied to those roles. And oh, by the way, they're going to get deleted after the TTL's up unless you manage to remember to renew them. There's also other things like you can throw all of your SSL certificates or SSH user passwords, whatever really, into a generic secret store, which is basically just nice encryption stuff around what's in essence a JSON blob. It has the idea of key rotation baked in at the forefront, where everything runs around the idea of tokens. Every token has a TTL, and when the token's up, it's gone. Everything that you've requested with that token is now gone. My favorite gimmick that Vault does is everything's encrypted with a master key. That's cool. Nobody ever sees the master key. I haven't read the source to figure out how you can get it, and I'm sure you can, but in terms of operational, nobody looks at it. How do you access the master key? Well, it's generated when you first initialize your vault, and then you get back a certain amount of unsealed keys, and then you have to provide a certain amount of those, generally less than the total amount back, using something called Shamir's key sharing algorithm. And this essentially allows you to have, more than one person have access to unsealing this entire vault system. I mean, it might mean you have to wake someone else up when you're on call, but the benefit in terms of OPSEC's probably going to be worth it. So we started making use of Vault internally, doing kind of an early adoption thing, and it got kind of interesting. We'll talk a little bit about that in a bit, but to make it a little less interesting, a little more, I'm going to say sustainable, we came up with a little tool that was, before it was open source, was imaginatively called Vault Wrapper. And I was told we can't call it Vault Wrapper, so we came up with a new name, Aomi, which is a anglicization of the Chinese phrase profound mystery, which seemed to fit. So it's an open source tool out there on GitHub, full-on CI/CD, and although I can always add more tests, it ships as Python packages, Docker packages. It's designed from our perspective to fit into continuous delivery pipelines. We don't want anyone to ever actually see the secrets. And we're going to talk a bit more about that in a moment. Oh look, more YAML. There's some YAML up there. So we're essentially looking for this basic YAML model to describe what these secrets are going to be. And we'll talk a bit exactly why we're keeping it separate from Vault. We're not allowing everyone to do their own stuff directly to Vault. You can probably guess what happened. And oh look, I have it right there. It turned into madness. We let everyone just write to Vault however they wanted to, and nobody could find stuff. Like you go to write something yourself and you haven't written down where it is, and it turned into kind of a mess, let alone if you're trying to share credentials and those sorts of things, or at least the access to credentials between teams. It got pretty messy pretty quickly. So a huge part of this, and essentially everything we're trying to do as a community project at Autodesk focuses on transparency. Everything lives in GitHub. Now, the secrets, of course, don't. Like, we're not going to keep our Amazon root keys in there. We're not going to keep whatever things people decide to put as generic secrets into Vault in GitHub, but everything else does. All of the metadata for these secrets. There's no reason for an ACL necessarily to not be visible to the people inside the company. There's no reason, for example, that a developer is like, oh, I can't launch my thing into staging because I don't have these AWS permissions. Well, because we're working on pushing a pull request model, they know where that repository is. They can submit the pull request and be like, oh, I actually need access to whatever of the 300 Amazon new web services they launched last week was. And we have a conversation in the pull request. Nice little change record there, and then the change gets made, merged in, and deployed out to the appropriate servers. So huge emphasis on pull request-driven culture, not just for the code itself, but for all of the associated metadata around that. And in order to do that, like this data model presents everything right in there, either in a set of shared repositories or a project-specific repository, so that the developers themselves can look at this stuff and manipulate it as they need. For better or for worse, the most commonly form use of secrets in our particular deployment is generic secrets, which is the catch-all for everything that we don't want to have to implement in a dynamic secret. We could also call it legacy. We can talk a bit more about that. The basic generic secret representation, you get a vault path, an endpoint, and you can throw a JSON blob in there, basic key value mapping. It doesn't really care what's going in there. The opinions that Vault itself is expressing are very minimal. And in terms of how Aomi is interacting with the generic secret storage or backend, we tried to make it very easy. You can throw a plain text file in there, a plain text file. You can use more YAML. You can just populate it with random data. Like, we shouldn't actually care what these secrets are because we're going to be rotating them constantly anyway, ideally. So in terms of the opinions, Aomi doesn't care. You can put whatever you want in for your vault paths. And we're not really enforcing this at this point. The emphasis is on the data model so we can find this stuff. Vault has its own constraints sometimes. You can't, I think the one that we've stumbled on across a few times is you can't mount another mount point on top of another one because they both disappear. There's some weird voodoo there. And AOMI doesn't actually enforce any of this stuff yet. Whatever you put in there, it's going to do as long as you know you have the actual permission to the vault server. Now let's start talking a bit more about the data model itself. It's driven by a file that we've imaginatively called secret file. It doesn't actually have to be called that, but it fits in the Dockers file, Jenkins file, make file, rake file. I had another one, I don't remember what it is. But it's essentially just a YAML file. And you have different YAML blob representations of different types of secrets. You have generic secrets, you have AWS credentials, local users, Duo, I could go on, pull request welcome. The secret file itself is also a template. It's YAML, Jinja 2. Anyone who's used Ansible is familiar with that. I learned a bunch of fascinating stuff about Jinja 2 yesterday that's going to cause me to reevaluate that, though. And again, to reiterate, it doesn't actually need to be called secret file. You can call it whatever you want. The intention here was for it to be almost actually dangerously flexible. It's built to just express those opinions on how you store operational secrets. You can do things like deployment environment based templates, so paths can be informed based on what your environment is, whatever variables people are being passed. You can have the paths themselves or the secrets themselves constructed by data you're pulling out of who cares what. You're feeding it YAML. It doesn't actually matter. The only limit is yourself. An aspect of this that we're trying to push, it's great to have the individual application teams and the products have a little secret file in there, so anyone coming in can be like, oh, this is how I get this credential, this is how I get this credential. They can never actually see the credentials themselves because the environments themselves are locked down, but they know how to access it. But one thing we found to be kind of interesting is where you have managed accounts by one group or another. And then, oh, we have a point of reference here. We know every one of these accounts of a particular service because, oh, it's there in GitHub. Oh, one needs to be added. Let's add the pull request for it. Oh, something's not documented right or it needs different roles. Well, you can make the pull request. So I mentioned the idea of deployment-based templating, deployment environment-based templating, and pulling data from external sources. We're trying to move into a point where nobody ever actually sees a secret except for security because they don't really have a choice sometimes. And in order to do that, we don't want to, or rather, as part of doing that, we don't necessarily want to slow down development efforts. So everything around this secret file and this idea of provisioning the operational secrets is happening as part of our pipeline. We have tooling out there so that product engineers manage the secrets that are contextual to their app, and we have tooling that promotes that to different environments. They have no access to that, but the data model is in essence what gets promoted. So they have some element of guarantee that those sets of secrets, potentially different paths, but accessible nonetheless, will be accessible throughout any environment they need to care about. So I'm going to talk just a little bit about this. It's kind of just more boring examples, but in terms of a generic secret, you can represent it from a text file. And then when you tell AOMI to go do its thing, it'll write that out to a path in Vault. So the little example down here, you can see the contents of the secret that are referenced by the YAML file. And there's some hand wavy there where we type AOMI seed and our Vault server's hopefully up and whatever. I decided not to do a live demo because reasons. And in the end, the thing's there and you can read it out. There's test coverage on this functionality though, you can check that. They're green last time I checked. You can also write secrets from YAML. So it's basically another key values blob. It just goes straight into Vault. Pretty boring stuff. Actually, I'm going to step back here a moment. So the things we have seen people put in here are, well, anything that you would otherwise base 64 and throw into an Ansible Vault or throw into an encrypted Chef data bag. Very similar with the YAML files, except that tends to be things like API keys, user key pairs, that kind of stuff. This one is kind of fun and was put in just to enable the promotion between environments. We don't want to ever look at secrets, and we don't want our developers to be aware of them outside of a tangential sense of metadata. And this just ensures that, no, when you run this, it's going to generate a random secret. Who cares? Nobody has to actually look at this thing. As long as all the tooling that needs to exchange the secret can access it, who cares? The biggest win for us has been the Amazon Web Service credentials. This is dynamic AWS creds. And this is a bad example because, we shouldn't give anyone administrator access directly, but whatever. Essentially what this will do is it'll provision a endpoint in Vault that and I touched upon this a bit earlier, that when you ask for credentials, you'll get credentials associated with a given role. And those are credentials that are good up until the default TTL of, I have no idea what Vault sets it to. Ours are a number that's based in reality, I like to think. And then after that's up, the credentials disappear. You can renew the token if it's, and thus the AWS credentials if that's something that Vault has been set up for. But other than that, it's on you to renew those credentials, and there's lots of tooling baked in there to renew those credentials. And the good news is that when you use Vault to mediate renewing these credentials, everything downstream from that in Amazon or other dynamic secret sources, dynamic secret endpoints, I guess, is handled. So there's a different other ways you can use AOME for. So we just talked about getting data into Vault. There's aspects of it that I was super gung-ho about initially, and now I'm kind of like, eh. And it's essentially on things to support legacy applications. And I'm sure people have differing interpretations of what legacy applications are. It's either A, things that were there before you got there, B, things that don't have tests, or C, something that habitually wakes you up when you're on call. I'm not going to define it past those vague things. But the different things that we had added to it do support that. Seeding, we talked a little bit about it though. You're taking that secret file, you're throwing it into Vault. It's a template. You can feed it with external data. Some things are going to need root, and it fits into a continuous delivery pipeline. That part is super key for us. We've given them probably too much flexibility, my bad. And with an emphasis placed on the low friction for adoption, we want people to be using this. We want people to be using the data model. In terms of seeding it, like you can have tags, you can choose at runtime what you're going to seed in. Maybe you're only going to just make sure all of your backends are there because you're the one with root and you don't want to deal with all the secrets. So just make sure the backends are there, make sure the developers can access it, and you're good. Cold storage is a relatively new feature in this, and it's based around the idea that every security department has at least that one person with a person-sized safe somewhere, and in there is where they actually write down like OpenSSL certificates on Post-it notes and whatever, or hopefully keep things on GPG encrypted USB drives. And that's what we're aiming for here. It's the idea of the complete cold disaster recovery. Oh, your backups are gone, that sucks. Well, you have your tooling somewhere so you can spin up Vault again, and we have all of our source code because hopefully we backed it up in a billion places, and then, oh, we have the cold storage sequence. We can just reprovision everything there, and we're good. It goes two ways. I called it an ICE file, the little artifact, because it sounded cool. I don't really know. It's just a GPG encrypted zip file or tarball. I don't even remember anymore. It does have test coverage, though. So this is where we get into the Linuxy bits, or the legacy bits. It's basically different ways you can pull secrets out. Okay, so you can upload a file into Vault using AOME. You can extract it out too, and it'll either spit it out to a file or standard out because legacy systems love plain text files and standard out. You can do the same thing with environment variables. I have a few regrets about this. And it basically renders these things out as environment variables, whatever the secret is. And there's a lot of flexibility in terms of how you massage the full name of the Vault path into whatever the actual environment variable is. People are going to abuse this. Guilty. You can do the same thing with AWS credentials. Guilty. I've abused this. But in essence, it's doing the same thing as previous, just contextualized down to AWS. This is a really easy way of taking a legacy application that is using almost anything that's based on an Amazon SDK. They all use the same environment variables. This is a one-line thing you can drop into your script, and boom, you have dynamic secrets. You can render templates out because, again, a lot of legacy applications read all of their configuration, including secrets from templates. So it's a Jinja 2 template, and you can control how the keys and paths are translated. There's a bunch of built-in templates as well that I added because I was tired of trying to figure out how to deal with different credentials and some of our CI stuff. So it's like, oh, cool, built-in templates. Don't have to do anything. I can just render out my credentials right there. And much like with just the basic seeding of Vault, you can pass in arbitrary data to this as well. So you can do things, I mean, I guess a good example would be like an artifactory thing. You pull the username and password from Vault itself using AOME, but the URL doesn't need to be a secret. That you just specify, or pulled out of an environment variable or wherever it is. So how did this go when we first tried it? It was kind of a mess. There were secrets everywhere, but they weren't in Post-it notes. They weren't in email. I'm sure there were still some in Box, but there shouldn't have been. They were no longer in Git. This is the important thing. We got secrets out of source control. The biggest issue was there was confusion around where to actually put things. Again, we're not enforcing any opinions at this point. We're just like, please use our data model. It'll make things easier in the future. So people just put it anywhere. Who cares? Because it's written down. We know where to find it. So Who likes greenfield programming? There's going to be more hands than with inner source. None? Really? Okay, one? Okay, thank you. And essentially, greenfield programming is super flexible. You're going to do whatever you want. That's what happened in our case here. So in terms of where we're going from this, hoping to heavily leverage emergent behavior, we're learning from each other on this. We're gaining early adopters, both inside and hopefully soon outside the company. And trying to build up, the important thing here is building up the momentum outside of the teams whose stated task is to work on this tooling. We're trying to build a community around this. So we're continuing to build atop of the initial concepts here based on how developers are making use of the system. And again, I've said this a few times, but it's like I don't necessarily care too much that it's messy. We can change the messy. We have a data model. We can gradually introduce stronger opinions. One of the upcoming features on this is essentially like style guides on your vault paths. It'll check your secret file, it'll check the vault server, and let you know if you're doing something you shouldn't be. And in order to enable that, it's like there's basic semantics for migrating from one path to another. And it's pretty straightforward, you know. Delete one path, the other one gets added. It's pretty straightforward stuff. It's just boring YAML. The effect here is it'll end up moving the secret from one place to another. You have a change record and that everything's tracked in Git. It's all nice and lovely. Now, in terms of what comes next for us, I think what's the joke? There's two hard problems in computer science, naming things and cache invalidation. And we're stuck on that first one right now. There's a lot of confusion around what to actually name things. Once we've decided, then we're going to start enforcing things. We'll be like, oh, why you can't write that secret there because it doesn't fit the convention. Until we have that, there's not much of a point to it. The biggest emphasis in terms of going forward, however, is to build that community. We have a few other tools on this around the idea of managing operational secrets. This is the one that's the most, I don't want to say polished, the most in use at this point. And we're essentially trying to curate those inner and open source tools, projects around that, and huge emphasis on pull request driven operations there. And the emphasis on what the tools are hopefully helping us with is managing operational secrets. In terms of AOMI itself, its feature set is complete but not fleshed out. Like, we're going to be adding more dynamic secret providers. However, we're not really going to be placing too much emphasis on the ability to pull secrets out. There's a bunch of stuff out there for doing that already. Console template's kind of cool because it just runs as a daemon and handles updating keys magically. It's kind of cool. We will be adding more secret types, as I mentioned. Going to support different authentication flavors. The priorities are pretty much being driven by community adoption at this point. AWS was a big thing for us, and then we'll see what other dynamic secrets people want. Before I wrap up, I just want to talk a little bit about this idea of Vault native applications, where everything I've talked about for extracting secrets from Vault. Okay, you write it to a text file, environment variable, template. These are all things that aren't really getting us any better than the status quo, other than that we don't keep things in Git. Vault is a RESTful API-driven application. You can have your application talk directly to it. It never needs to write secrets out. Only keep them encrypted in memory, decrypt them when you actually talk to whatever API you're talking about. Key rotation, nobody cares anymore because the system's just going to do it. And the hope around this, going back to what I was saying before, like less emphasis on legacy secret extraction, more emphasis on seeding, and more emphasis on these community endeavors so that we're not all duplicating our effort there. And then in terms of the biggest thing, and the past 2 days have been a great example of why we need to do this. It needs better data validation. That's pretty much it. Like, we can't trust anything that people are putting into YAML files. Can't trust whatever's coming back from the Vault server even. So all of that has to be more rigorously validated and tested. And this is up on GitHub. So if there's any questions, I'm fairly easy to find on the internet and or around here, I guess. And yeah, that's it. Thank you very much. Pull requests welcome.
Thank you very much, Jonathan. On behalf of Fitbit and BSidesSF, we'd like to present you a Fitbit Alta, reminding you that motivation is your best accessory. There you go. Oh, absolutely.
So I've noticed we've been giving out Fitbits, and Fitbits do sleep tracking. There is a fascinating talk at DevOps Days a few years ago where they attached PagerDuty to their Fitbits. I suggest you try and check that out. I know, right?
Quick announcement. If anyone is wanting an awesome bear board from Bear Sprite to populate your own electronic badge later when we open source the design, I'll have a couple down here in about a minute. So just find me.